All right, so this example is number 62. Off of your homework here. And it says this. It says r of x is equal to x cubed plus 4 divided by 2x squared plus x minus 1. First thing we're going to do is we're going to factor this out. So that's r of x is equal to, now this numerator, I can't factor anything out into the numerator here. But that's okay because all I have is a cubic term and a constant term. If all you have is a power term, in other words like x squared or x to the fourth, and you have just a constant term, then you can just solve that out for 0 just the way it is. There's no factoring that needs to be done at all. So what we're going to do is we're going to leave the numerator the same, plus 4, and the denominator we're going to factor out. And we're going to factor that to be 2x minus 1 and x plus 1. So once we're here, we can find the zeros. And the zeros are given by setting this portion, the numerator, equal to 0. X cubed plus 4 equals 0. That means that x is equal to the cube root of negative 4. Now, the cube root of negative 4 does exist. It's just a number. You can take the cube root of a negative number, but not the square root. So that's the only thing you got to be careful with here. So that tells us our zeros. Now we can find our vertical asymptotes, our VAs. And that's going to be at 2x minus 1 equals 0 and x plus 1 equals 0. So I have two vertical asymptotes. One of them is going to be at x equals 1/2. And the other one's going to be at x equals negative 1 right there. So let me circle this over here. And if somebody could give me an approximation to this value, I'd be much appreciated. Much appreciative. All right, so now that we have our zeros and our vertical asymptotes, let's figure out what our horizontal asymptote is going to be, our HA. Now, the HA is always given by the degree of the numerator and the degree of the denominator, how these two play nice here. And if you notice, we have a higher degree in the numerator than we do in the denominator, which means we're going to have a slant asymptote. What's that? Well, it won't be 0. It's only 0 if the denominator is bigger. When the numerator is bigger, you're going to end up with a slant asymptote. So I have to do a little bit of long division here. So I take x cubed plus 0x squared plus 0x plus 4. And I'm going to divide that by 2x squared plus x minus 1. And now we can figure out how to solve this out. So how can I make 2x squared into x cubed? Well, you can multiply by 1/2 x. And if I multiply these out, I get 1/2 x times x squared gives me x cubed. 1/2 x times x gives me plus 1/2 x squared. 1/2 x times negative 1 gives me negative 1/2 x. Put all of that in parentheses and put a minus sign on the outside. That means that all the signs are going to change. Those two will cancel out. This will become a negative 1/2 x squared. Becomes a positive 1/2 x. I drop down my 4. Put a plus 4 there. Have I lost anybody so far? Good. All right, so now I can start over again, and I can say, well, how can I turn a 2x squared into a negative 1/2? Yeah, I'm going to multiply it by negative 1/4. So I multiply this by negative 1/4, and I do end up with negative 1/2 x squared. Negative 1/4 times positive x gives me negative 1/4 x. Negative 1/4 times negative 1 gives me positive 1/4. I go through here, put my minus sign on the outside. That's going to change all the signs on the inside. So those two are going to cancel out. I'm going to end up with 1/2 plus 1/4, which is going to be, what's that? 2/4, 3/4. So 3/4 x plus 4 and 1/4. That's going to be 17/4 plus 17 over 4. And I can't reduce this any further. Excuse me? No, we changed the sign. So it should have been, oh, no, yes, you're right, you're right. It should be subtracted, so that's going to be minus 1 is going to give us 16, minus another 1 is going to give us 15. 15 fourths. And this is the equation that we're going to use. Oh, I'm sorry, no, this is not the equation. This is just the remainder. So we don't have to pay too much attention to the remainder. What we really want is we want our quotient. So I have a slant asymptote at y equals 1/2 x minus 1/4. Does that match up with what anybody got out there? Yeah? Good. So we have our zeros, vertical asymptotes, horizontal asymptotes, which actually turn into a slant asymptote. What's the last thing we have to figure out here? Yeah, our y-intercept. And how do we figure out that y-intercept? Yeah, set x to 0. So we're going to evaluate f of 0, and that's going to give us our y-intercept. So f of 0, if I go in and I plug in a 0 everywhere I have an x, that's going to give me 0 cubed plus 4 divided by 0 plus 0 minus 1. So f of 0 is going to be negative 4. So we can start a new sheet here and begin to create our information wave. If you notice, both of our coefficients were positive in the numerator and in the denominator. So that means that I'm going to start at the right, on the top right-hand side. First, I'm going to make my little info wave here. So this is my info wave. Make a little 0 right at the center there. And now let's take a look at where we have zeros and vertical asymptotes. So I have a 0 at the cube root of negative 4. What is the cube root of negative 4? Somebody out there? 1.587? Negative 1.587? Let's call it 1.5, negative 1.5. So I have a 0 that's about right here at negative 1.5. I have two vertical asymptotes, one at 1/2 and one at negative 1. So I should have given myself a little bit more room here. We can make it work. Turn that into a proper asymptote. So there's one asymptote, and I have another one at positive 1/2. So that's going to be negative 1, and this is positive 1/2. And I said that it was going to be a positive graph, so that means I come up, I start over here, and I don't have any multiplicity. None of my zeros repeat here, or none of my asymptotes repeat. So I'm just going to go ahead and walk right through them. Walk right through there, right through there, right through there. And that's what our end behavior is going to look like. So if you're thinking about it, this is what it's going to be. It's going to be negative, 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 negative until we cross above. And then we're positive, 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 positive. And then we go back to negative, 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 negative. And we end up on a positive note here. Positive, 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 positive. OK, so now we can lay out our graph. And I'm going to go ahead and make this line right underneath here. So this is going to be my y-axis here. And you don't have to line them up vertically like this. Sometimes it does make your life a little bit easier, but it's not absolutely necessary. So we're going to come through here, and we're going to draw in our slanted asymptote. And our slant asymptote was at, our y-intercept is at negative 0.25, and we're going to go rise 1, run 2, because our slope is 1/2. So I'm going to come down here to negative 1/4, more or less right here. And then I'm going to go take a nice easy slope, up 1 over 2, up 1 over 2, up 1 over 2. Something like that. It just has to be a rough sketch. And as long as I label what my asymptote looks like, I'm not going to be too picky about what these things look like. Just know that the slope, the lower the slope is, the less steep the line is going to look. Because you will not be able to use a calculator when you graph these. So there's that. And we can put our vertical asymptotes. One of them is going to go at positive 1/2. And let me just see here. If you make it positive 1/2, that means we're going to be right here where we cross. So let me take my line there. And there's that vertical asymptote, and that's at positive 1/2. And the equation of this line, we always want to write our equation, the equation of our line on here, and that's going to be y equals 1/2 x minus 1/4. There's that. We have 2 asymptotes. The other one goes at -1. So I'm going to go ahead and put another one right here. It's going to be at -1. If you want to get real persnickety about it, you can find this intersection here just to make sure that everything lines up. But I'm not going to ask you for those sorts of things. As long as you have a nice rough sketch, I'll be pleased. All right, and we have a 0 at -1.5. So I'm just going to put a dot right here at -1.5. And be sure and label this guy right here, -1. Okay, so now we can start to graph. After all of this work is done, now we can begin to graph. And I remember that I always start right along that asymptote. Always, always, always. Draw them out nice and far so you don't have to deal with any kind of craziness. Draw them in. Because we're going to drive right along this asymptote here until we have to poke through some numbers. So I'm negative up until I get to -1.5. So I should have gone a little bit further like this. Go kind of right through that there. And we're going to be positive every time we're on the left of this asymptote. So even though it looks like I'm going to crash into it, I'm just going to follow straight up. And that's what it's going to do for me there. And you could have drawn this out just a little bit further and maybe gone a nice smooth line there. So if we look on the right-hand side, when we're between -1 and positive 1/2, we're going to be negative the whole time. So I never cross through the 0. There's no 0 between these two asymptotes. So I'm never going to cross the x-axis. So all I really do is I come up from the negative side. Right, that's that point. So I'm going to be negative, and I know that I have to stay negative on both sides. So what you can do is you can come up, and we know we have to cross through our y-intercept, which is right there. Is that right? Yes, that should be our y-intercept. Oh, wait, no. Our y-intercept is at -4. I forgot to label that on there. So -4 is going to be about right here. That's my y-intercept at -4. Come up, go right through it, go back down, and we're set. So now we can look at what's happening on the right-hand side of this asymptote here. And I'm positive the whole way through. I know that I have to come from the positive, come right along the asymptote here, and go up and out. And that's what the graph looks like.